Okay, guys, I'm just going to finish up Unit 4 with one video, just kind of going through everything. There's not much for me to talk about, really, that's not kind of straightforward. So, Unit 4, Activity 3, we're going to look at misuses of data, uses and misuses of data. So, as you work through here, you'll see, we'll talk about misleading graphs. I think that's self-explanatory. This one's a little different here. Confidence levels and margin of error. We're not going to spend too much time on the math behind this, but for example, I think this is good. Here it says that poll says 24% of Canadian population could not afford this with a margin of error of 1.3. So what that means is a margin of error means this is what I think the answer is, 24%, but my margin of error, it's a statistical measure, and that means that I think it's 24%, but I might be wrong by 1.3% up or down. So what you do is you take the 24 and you subtract 1.3 to get 22.7%, and you take the 24 and add 1.3 to get 25.3%. So you have what we call the upper and lower limits. So here, that's kind of what they show you how that happens here. And that's what margin of error is all about, okay? So it's a upper and lower limit. Where it gets kind of cool, I guess, one example. Give me 1 second. I'm just going to open something up. Some of the uses for this is when you're comparing things. So, for example, when you have an election, let's say at Party A and Party B were running for election, and I said that we had I thought that these guys had a 39 points. I don't know. No, let's make it a little bigger. Let's just say there's just two parties. So we'll be very American here, just the two-party system. And we have Party A and Party B, and I have a 51.9%, 50.9% of the people are going to vote for me, and 48.0% are going to vote for you. Okay, so that's A and B, and then the rest is other parties or whatever. But I say that I have a plus or minus a margin of error of, let's just say 2%. Okay, so 2% margin of error. And the question is, am I confident that A is going to beat B? So what you do is you take A, 50.9, and then you add 2%, okay, to get all the way up. So if I add 2 to this, I get 52.9. And then I subtract 2% to get 48.9. And that's my, what we call my lower limit and my upper limit for Party A. Okay. And then for Party B, sounds like I'm saying Cardi B. Party B, I think I'm at 48%, which is down here. Okay. But when I add 2%, so again, I'm going to have a margin of error 2%. When I add 2%, I can get up to 50% of the vote or 46% of the vote. So that's my lower limit here and my upper limit here. And because there's overlap here, there's a chance that Party A has 48.9%, which is less than the upper limit for Party B. So there's a chance that these guys are at 50%. There's a chance that these guys are at 48.9%. If that's the case with the overlap, if I was a pollster, I would not say that Party A is going to win for sure. Okay. There's overlap between the lower limits and the upper limits here, the ranges of the potential data. So that's where we use this sort of thing. Okay. So that's about confidence intervals and that. All right, so that's the uses of confidence intervals and margin of error. So you can take a look at those examples there. I hope that helps a little bit. And there's some videos here. There's not much to do. There's different types of bias, sampling bias. So basically what's going on, any sort of bias is when the population doesn't represent the population is not represented by the sample. If it's different types of sampling bias include things like non-response bias. So non-response bias is when people don't answer. In general, bias means population isn't represented by the sample. So you have a sample, you look at the sample. I always talk about Costco, right? You go to Costco, you get a little piece of sample, and if you get some pizza there as a sample, and then you take it home, it doesn't taste like the actual pizza that you bought, that's not good. So that's kind of what bias is. I have a sample, and whatever I did or whatever the reason for it, I don't have the same thing at home as I do at the store. So my sample doesn't represent the population. Is it because someone messed up? Is it because someone overcooked it? Is it too dry? Or did I mess up at home? I don't know what the story is, but it doesn't represent, the sample doesn't represent the population. So, that's what bias is. Is it because that people didn't respond? Okay, that's non-response bias. Is it because you messed up in measuring? That's measurement bias. Is it response bias that people are choosing to give me a bad answer, or I've set up the question so that I'm getting a bad answer? That's called response bias. So these are all just different types of bias. They all lead to the same thing, that my sample that I'm looking at isn't representing what I want it to, which is the population. Okay, so that's that for that one. Give me a second here. I don't know what I'm drawing. I don't have any idea. Oh, jeez, old man. I feel like an old man right now. Give me a second here. All right, so that's 4.3. 4.4 is collecting primary data. So we're going to look at primary data. Primary data is data that you collect. You go and get it. So take a look at this article here, and then you look at different types of studies. You have experimental study, or so when you have an experimental study, that's where. Sorry, let's go back. Cross-sectional studies is you're looking at something right now. Longitudinal study is you're looking at something over time. So cross-sectional, sometimes you can compare things in a cross-sectional study. So you might have two different groups that you're looking at right now. So if I have two different classes, I can look at what's the class average in class A, what's the class average in class B, and compare them. Longitudinal will be more something like this. How is class A changing over time as I do something different? Okay, so now that I'm giving them more time for homework, is that changing their results? So that's longitudinal. Okay. Control group is if you're looking at an experiment. Okay. An experimental study is a study where researchers controls what's happening. So usually what you have is a treatment group and a control group. You have the treatment group is the group that is just left alone. And sorry, the control group is the group that's left alone. And then the treatment group is the one that you, treat, I guess, right? So a simple thing would be, in the example, there was two treatment groups, one with smartphones in the bags in the living room. So that's this example here above. Another one, you can just think of this. If it's a drug study, these guys are not given the drug. These guys are given the drug. What happens? Are you healthier? Are you whatever we're looking for? Okay. A lot of times you have to give something called a placebo. So give them a fake pill. So you don't know if you're in the control group or if you're in the treatment group. That way you can't kind of, lean one way or another. There's different types of studies, blind studies and that sort of thing. We won't get into them too much. And then you can just keep reading here about the different types of studies. So nothing really that heavy again in this section, as you can tell. Just know what these things mean. These are really things, when it comes down to it, you're not learning a new skill here. You're just looking at, which is what we do mostly in math. So this is a little different. You're just becoming aware of that these things exist. At no point really in your lives or in your math lives are you going to be asked to just produce these things, right? So it's not like you're learning a skill like multiplying and you have to know how to multiply. These are just terms and things that are out there. You will see them as you get older and you move into your further studies, university studies, right? So no matter what you take, you're going to see all these things come up and talk about biases and different groups and all that stuff. So let's talk about sampling the population, different ways to sample the population. There's a lot going on here. So there's random sampling. Okay. So when you have random sampling, you try to get something that's completely random. That's easier said than done. Number generator is a good way to do it. We used to just open the phone book and randomly point to a name in the phone book, if you know what that is. But that's kind of difficult to do. So what you do is you try to come up with a procedure that will make your sample kind of random. And the one is systematic random sampling. So systematic is when you take a certain person. So, let's say the 10th person or the 15th person. So I will have a list of students and I'll go down and take the 10th student. Then I'll take the 20th student. Then I'll take the 30th student. Then the 40th. Okay. Or people are walking through a door. I won't ask them all a question, but I'll ask the 15th guy and then the next 15th guy and the next 15th. And you're hoping that gap between things will force randomness to your sample. Stratified random sample and cluster sample are very similar. Multi-stage is the third one. So I'm going to start with multi-stage. This multi-stage is like the complicated one where you go ahead and you do a bunch of stuff and you put them in groups and then you analyze them that way. But these two, I think, are easily confused. Stratified is when you put groups in strata or you put your sample in strata or in groups and then look in the group and ask a certain group, the right percent of the people in the group a question. So I might have done a bad job explaining that. So let me just kind of explain that here. What stratified versus cluster. These are easily confused, but I will help you. So just think of a classroom, okay? So I have, or think of a school, okay? So I have grade 12s, grade 11s, grade 10s, and grade 9s, and I have 30% of my class school is that, 30% is that, 25% is that. So what's that? 60, 70, 85, 15% is grade 9. Okay. So I want to ask the school, my sample, my population is the entire school body. So I want to ask them a question. What I would do is get a group. I would have a sample space here. So if I have 1,000 students and I want to just get 10%, I would ask 30 people from this, that are in grade 12. Then I would ask, 30 people from here and 25 people from here and 15 from here. So I put them in the strata, in the classes, but then I ask the appropriate proportion of each strata a question. Okay. So there's more of these guys than there are of these guys. So I ask more of these guys than these guys. Cluster is a little different. It's a little easier. So what I would do for cluster is if I want to get some information here from grade 12s, 11, 10s, and 9s, I would go and find out a bunch of grade 12 classes. So let's say there's all these different grade 12 classes, and I would go to one of the classes and ask everyone in the class a question. So I always think of this cluster CL, class CL. So you break them down into groups, and then you ask the entire group. So here you're asking random people from the groups. So now here I have, you put them, like I said, in strata, and then you randomly choose things here. In cluster, you go ahead and you ask a whole grade 12 class, a whole grade 11 class, a whole grade 10 class, a whole grade 9 class. Okay, so those are the differences between cluster and stratified. Okay, and then there is also, non-random sampling. So these are kind of bad. Voluntary, you ask people to answer a question. That's going to be, you're going to have bias there because who's answering the question? Probably people that are have a strong opinion one way or another. Convenience sample is kind of the laziest. You just turn around and you ask the people that are near you a question. Okay, so you're not going to get randomness there. These are different biases. So you have sampling bias. The bias itself is bias. So we've already kind of gone through this. Non-response bias. They're not talking about it and that sort of thing. So just know the difference between these. You're not going to be forced to know them out of the blue. So that's the different types of sampling. So finally, the last part is collecting data and asking questions, right? So please, when you click on this link, it sends you to this Survey Question Pro, and they go through the different types of examples of questions. Please don't spend too much time on this, okay? So there's different questions, multiple choice, open-ended. Just know this, okay? When you ask questions, if they're open-ended, you're going to get, that's where you ask a question and then the response is written down, essentially, right? A closed question will just give a certain amount of answers. So if you're doing that, you're choosing what the possible answers are. You want those answers to be you want the question and the answers not to be too leading, okay? And then you can go ahead and take a look at this. Don't overdo this. Just take a look at it, know these things, and that's it, okay? So the unit itself, a little bit different, a little bit softer, I say, less mathy. We get straight into 1 and 2 variable stats soon, and then we finish this with the distribution tables and that sort of thing, which is really mathy. So that's going to finish the course. So we're almost done. 2 more units left, and then that's it. Okay, so a quick unit. Take care. Bye.